In this chapter, we're going to start talking about derivatives and antiderivatives of the natural log function. So previously, the only rule that we've had for taking an antiderivative besides the trig ones is if you have something raised to a power, and the rule was add 1, divide by the power. Now, this will work for all cases except when when you have 1 over x. Because if you try to do the power rule here, notice this is the same as x to the negative 1. If I add 1, divide by the power, you get x over 0, which we cannot divide by 0. So it doesn't work for a problem like that. Okay? So we're going to start with the derivative first. So the derivative of the natural log of a function is 1 over u times, always chain rule, du dx. So if I ask you for the derivative of the natural log of x, is if this is f of x, then our derivative would just be 1 over x. That's the rule. And these are some properties of logs that you will need later to go ahead and simplify some of the answers that we get to. Okay, so let's just go ahead and do some examples. So the rule is the derivative of the natural log is 1 over the function, and you do not need or you do not want the absolute value in your derivative. This is just there because it's saying you cannot take the log of a negative number. But the slope of a log function, depending on what it looks like, can be negative. So f prime is 1 over x squared minus 6. Don't forget chain rule on that entire function, which would be 2x. Okay. Sometimes it helps to rewrite it using your properties of logs first. So this is really the same as natural log of x plus 1 to the 1/2. And one of the properties of log says that if you have an exponent, you can go ahead and bring that to the front. So this will make this problem much easier. So the derivative is the 1/2 is just a coefficient, leave it, times the derivative of the natural log is 1 over x plus 1. Chain rule just gives you 1. Number 3. Derivative is 1 over 4 plus 5x minus 2x cubed. Don't forget your chain rule, so 5 minus 6x squared. Okay, number 4, you have the 2 on the outside, so you need to bring down the 2 first, reduce the power by 1, then the chain rule on the inside, the derivative of the natural log is 1 over x. Okay, these last two problems, now, if you try to take the derivative as is, it's going to be complicated because you've got a power rule going on, a product rule with chain rules. It is much simpler to rewrite it using properties of logs first. So I'm going to rewrite this function as, I know when I take the log of the product of two things, it's the same as adding them. And since this is a square root, I can pull that exponent in the front, plus this 3 goes in the front of that one, natural log of 4x plus 5. So using the properties of logs from pre-calc, rewrite it first, then take your derivative. So 1/2 times 1 over 6x minus 1 times 6 plus 5 over 4x plus 5 times 4. Same thing on number 6. I'm going to rewrite it using your property of logs. So that's 1/3 goes to everything because everything's underneath the cube root. When I divide, that's the same as subtracting the log. So I can rewrite it like this. So the derivative is, pull the 1/3 in the front, 1 over x squared minus 1 times 2x minus 1 over x squared plus 1 times 2x.